Color systems. You either love them or you hate them. I love them. I overuse them a lot. I think I'm making. And I couldn't press it enough. I a lot when I write rare variables, which you will know more about in the future. But variables are a way of storing values in a neat way in CSS. They are called custom properties, not variables. But usually developers we're calling them variables and they say because that's what they are in a sense. So color systems, I use them a lot in these cases. And colors, why would you use them? I mean, even black is a color. White is also a color. Even though you like, maybe mathematically or in physics you would say black is less of a color, but still, in this world we see it. We have to define what black is. So uh, we're going to talk about three separate color systems, and these are red, green, blue, RGB. So if I ever say RGB, it's not a weird acronym. It stands for red, green, blue. And then we have the hexadecimal ones, which also takes care of red, green, and blue, but in a different way, and we'll soon learn how. And then we have HLSL, hue, saturation, and lightness. Color systems are beautiful because they are handling the things we see in everyday life. Even though we have severe color blindness, or maybe you see in monochromatic, these whites and blacks are also, in a way, in a sense, colors. And what color is it all about? I don't want to go deep into physics about it, but it's basically what gets reflected back at us due to the light interacting with things around us and their electrons. So most of the light get absorbed and become energy instead of bouncing back. But because some of them do bounce back because of uh, chromodynamics and how it works with quantum mechanics and so on. As I said, I want to go deep into it. They bounce back to our eyes and we see it. And we experience the world through color, most of us. And when we talk about colors that we see that way, the physics of it, we are talking about red, green, and blue, actually. If you come to us from school and you've been painting a lot, you might talk about other colors, like saying red, blue, and yellow, maybe. Uh, it wouldn't make me very surprised if you had. But if we're talking about the real colors, the colors that we are actually perceiving everyday light and use our eyes, and we had to pick colors that easily, mix those up. And we don't talk about the pigments you use on a paper. We're talking about things we see on screen because that is the luminosity, or it's things we get from the sun, the things we perceive with our eyes. Well, divide them up in different colors. We use red, green, and blue there. So red, green, and blue is there for a reason. Now, in our eyes, we have much more, focus on green. There's so many. We have the rods and cones, and we have so many more that focus on green, so we can see the nuances in forests and woods and stuff like that. Then we do have red and blue. But even so, we see red and blue, and they're actually red was something we really react on when we see it. It's dangerous, and blue might be calming, and green might be calming as well. I don't know. Blue could be freezing. They have so many values to us, cultural and also global. However, the case without and the background story of colors, we use them a lot to provide information or context about the information that we have. We really use color in a good way. We can get far with that. To do that on the web, we need to know the systems for it. And the three I will present are these three. So let's go ahead and talk about what's in there. So if I went to Visual Studio Code, and I said I wanted to change the text color or the background color, I could say color, colon, and then type RGB and type, and then in these values, you see in this parentheses up there, I could first paste the type of value of between 0 and 255 for how much red I want. If I want all it all to be red, the full red thing, all red in there, I would go to 255. So I would go max out at the red. And the same goes for green then, after this comma. I could max out at that. And if I max out at the blue as well, I would have maxed all the colors. And if I have all the colors, I think you know what I'm talking about, we'll get to white. So all the colors together is white. And none of the colors, that's black. So 0 and all is black. And then we can mix, so we don't have to have the same value on all of them. We can have like 0 on the red, and then we could have 255 and green and blue, and then we get some kind of turquoise or cyan. And if we mix blue and red, we get some kind of purple. If we mix green and red, we get some kind of yellow. But these are very, very, basic mixing. So we could make all the kind of nuances and mixes we want there, all between 0 and 355 for all of them. So in effect, we could say that 0 to 255, that's 256 different values, because 0 is a value in and of itself. So each of them have 256 different values. And if we take 256 times 256, we get all the kind of combinations of values that we can make, which is a lot. I don't remember right now, but it might be like 60 million, something like that. I don't remember. But it's a lot. And then we have 0 to 1. What does that stand for? It's in the very end there. 0 to 1, it's what we call alpha. And it's not about some kind of alpha male or alpha dog or whatever. Actually, 0 to 1 is alpha. It's how transparent something is. So if I say 0, we will actually not even see the color. It will just be fully transparent. And if we put 1, it would be opaque. We cannot see through it. And any value in between 0 and 1 would be more or less opaque, more or less transparent. See? So you can see through. Now, that is true there. And if you go down to hexadecimal, it's actually the same thing going on. We have a hexadecimal value, red, green, and blue. And the first two characters that we use, numbers or 0 or letters, are handling the red. The second two are handling the green. The third, the third pair, that's actually the blue. And then the alpha are the two final ones. Okay, so why would we do that? It's actually a neater way of writing things than the above one, because it's computationally less heavy. And that's also the first way we had to write colors within CSS. Now, how do we really know what this means? Because you will see this a lot. When you see the hexadecimal, people use it a lot. How do you know it works? And we'll also get into this HSL thing later on. And let me first introduce you to it, because it's totally different. It doesn't really work like this at all. It separates things more as we think about them. We say hue says tone. It goes from 0 to 366. So it goes from red to red. It goes over the whole spectrum of the, what's called the rainbow spectrum. So every color goes from 0. And then if you go from 0, from red to red, you will certainly go from orange, yellow, green, and then go to turquoise, blue, purple, magenta, and then you go back to red. So you get through all those colors and a lot more, of course, between. So this is the tone, the hue of it all. And this one, saturation, is how saturated it will be. You know, you get these colors up here, they're very saturated. This red over here, it screams at you, but you could have a red that is not screaming as much to you, that it would be less saturated, so desaturated. So saturation really handles how saturated. Zero would be gray, basically. You would have picked a tone, but it wouldn't matter. It will become gray anyway. But then if you increase that hue a bit and get up to 100%, you would have it a screaming color. And then if you could have something in between as well, 0 and 100%. Lightness, it says what it does. It handles how light the color is. Is it going to be like a really light color approaching white? Then it would go 100%. And approaching black, it's 0%. And anything in between. And then in the final part of it, we have the alpha as well, which works exactly the way it does up here in RGB. How transparent will it be? Now that is the overall view. And the next part of this lecture, we'll actually talk about converting between RGB and a hexadecimal and vice versa.